Hello, welcome to today's lecture on modeling Autosar basic software service calls. Okay, so in the previous lecture, we got introduced to the Autosar toolbox in MATLAB environment. So in this lecture, we will start modeling the basic software function calls in MATLAB environment. Okay, so this is going to be performed under the Autosar Classic platform, and for Autosar Classic platform only, like we are going to do the whole thing, and we are taking a NVRAM related functions and blocks to implement this function. Okay, so the agenda of today's discussion is about the Autosar basic software service calls. The next one is the Autosar BSW service call Simulink library blocks. The third one is configure calls to NVRAM manager, then the steps to configure NVRAM manager service related calls, and the last stage of it would be the code generation part. So now let's quickly move into today's discussion. So Autosar BSW service calls in MATLAB. Okay, so this is a classic platform approach, and for this classic platform related Autosar approach, Autosar standard defines important services as a part of this that runs in the Autosar real-time environment. So these services includes the diagnostic event manager, function inhibition manager, and NVRAM manager. And in Autosar real-time environment, Autosar software components typically accesses the BSW services like client server or send receiver information. To support the system level modeling of Autosar components and services, Autosar block sets provides an Autosar basic software library, and using these basic software libraries, basically have some pre-configured function callers which is going to be useful for modeling of the Autosar BSW services. Okay, so this is with respect to the Autosar BSW service calls in MATLAB. We have three common Simulink library blocks which we had already seen. Okay, so one is diagnostic event manager, function inhibition manager blocks, and NVRAM blocks. So in the MATLAB that we have seen in the previous lecture, it was about the diagnostic event manager block and NVRAM block. In diagnostic event manager block, again we just had two features or two services, which includes the diagnostic info caller and diagnostic monitor caller. So as I said, it includes two basic services. One is diagnostic info caller and the next one is the diagnostic monitor caller. Apart from that, a diagnostic operation cycle caller and diagnostic event availability caller is also there. And apart from that, FIM blocks are there, which unfortunately I do not have with my MATLAB. And finally, I have an NVRAM manager block which includes NVM admin caller and NVM services caller here basically. So now what I am going to do is, like, I'm quickly going to go to the MATLAB environment. Okay, this is the model that we are going to take for today's consideration. Okay, so first I'll try to explain about the model, what this model is, and from that we will try to quickly move into the Autosar implementation part. Okay, remember when we tried to create a new software component, we had an integrator block that is coming available with it. And apart from this discrete time integrator, there was also, we are also adding a rate transition block over here. Here, this is going to denote, so in1_1s and in2_2s, they are going to denote two separate runnables for me. To indicate that these are two separate runnables, I have two subsystems which is present over here, SS1 and SS2, each of which are having different logics. So now the assumption is in such a way that I have two runnables, each of 1 second and each of 2 seconds separately, and this is my setup and this is my configuration. So the ultimate objective in this system is to make use of NVRAM function, and then we have to do code generation and see whether BSW software code is being generated appropriately. So that's the whole funda behind over here. So what I will do is, first I am going to take this MATLAB model. So this is already present in a subsystem. This is already like present in a model. I'm going to take it into a separate model. And then in that separate model, what are the configuration parameters basically we need to take care of? Okay, so you need not take care of all the configuration parameters before code generation with the help of model advisor and all. Just the basic configuration parameters, what you need to change, that we will change, that we will update, and then that will be followed by the other processes with respect to this NVRAM manager and BSW function call implementation. Okay, so I have selected this feature, I am copying it, and I'm clicking on a new model. Okay, so I am pasting it over here, and I am trying to save this model into the same location. Okay, I'm saving this model into the same location as I've already having it as SWC Autosar. I'm just giving SWC Autosar NVRAM over here. Okay, so it is taking some time to save it. Yeah, so once this is saved, I'll click close this, and this is going to be further taken for all the analysis and work. All right. So before going, we have already seen what is the most important setting with respect to the code generation. So those are my system target file. You need to understand what corresponding TLC you are using, and then that will be followed by the solver settings. So first we'll see the solver settings. The default solver setting in this model is variable step. Convert it to a fixed step, and then convert it to discrete, which is no continuous state. Okay, click on apply. The next one is with respect to the code generation. System target file has to be Autosar. See, in the previous lecture we saw what it is for Autosar, what it is for adaptive Autosar and all. In that we have to choose my target file as autosar.tlc. Okay, so I am choosing it as autosar.tlc, and I'll save it and I'll close it. Okay, fine. Okay, my model settings is now closed. I have saved it. So this is a discrete time integrator block that we have. Apart from that, I'm also having a rate transition block. I am going to consider my SS1 and SS2 as two different and two unique runnables over here. It's just a very basic representative calculation that we are having. This is a very basic one. Okay, first signal value is added with 3 times the second signal value. Okay, and likewise here 2 times the first signal value is added with second signal value. This is something like a linear equation, how they will look like. Exactly the same was only there here. Okay, as far as the SS1 and SS2 logic is concerned. Okay, so this is my model. So now once after I have created this, okay, that is I have made this into a compatible format for code generation. I'll just try to simulate this model and see whether it is simulating fine. In first place, I have made the appropriate changes in config parameter. We'll see whether it is simulating. Yes, simulation is going on. Compilation is happening. Yes, simulation is done. So the next stage here would be is to add the corresponding BSW function calls to this model. Okay, and then based on that BSW function call related code generation we are going to do and see. So for that, what I am doing is I am going to select the simulation tab. Under simulation tab, library browser. Under this library browser, I am choosing my NVRAM service caller. Okay, I am taking the NVRAM service caller, I am selecting it and I am dropping it inside my model. Okay, it is immediately asking in the pop-up for my client port name. Here I'm going to just keep the default client port name. The reason is we are only considering one model here, and that for that single model only we are using one NVM service caller. So whatever be the name that you have, let's go with the default name itself over here. Okay. And apart from that, let us choose this value here as read block. This operation, corresponding operation, whatever it has to do, that we will choose it as read block over here. The moment it is choosing as read block over here, an additional parameter comes in, okay, which is argument specification. About this argument specification and all, in the previous lecture, no, while we were introducing you up to this block and all, that time we did not learn about this argument specification. Only here it is given. And one more thing that you can see over here is that this is supporting only uint 8 and one dimensional, which means whatever function call signal that you are using, it can be of data type uint 8 and it can be a single dimension one. You cannot use a multi-dimension signal, or you cannot use a vector value, or such kind of values cannot be used. And uint 16 or uint 32, you cannot use them. Something, if this is uint 8 of 1, you can't use something like uint 16 of 4, uint 32 of 4, etc, etc. For this MATLAB version, I think, I'm not very sure, but I think for 2020, all of these points are taken care of. Probably if anyone is going to use 2020 for their application, you can go ahead to test it with 2020. You can probably make an understanding or update from that. But here, the default one is uint 8 of 1. It takes uint 8 of 1 only. So the client service port name I am giving as NVM service. The read block, I am choosing this operation as read block, and then from this I am choosing my argument specification as data type uint 8 dimension 1, and my sample time by default is -1, that is there. So what does my read block does here? Read block, it requests to copy the data from my NVRAM block to my corresponding RAM block. So this is what it does. So I am clicking on apply. Okay, so after doing this, what I'll do is there is an error port, and apart from that error port, there is a data port. So let us terminate the error port in first place. Okay, so after connecting this, I am terminating my error port in first place. And apart from terminating my error port, what we will do is, like, since we have to record and observe the value in memory, let us take maybe something like a data store memory block, and let's write the output that is coming from the read block. Essentially, whatever request data that is going to be copied from my NVRAM block, that is going to be written into my data store memory block. So I'm going to use a data store write block, which is going to write down all this thing. So whatever that is being read in my NVRAM is going to be written correspondingly into this. Okay, so I am taking a data store memory block. I need not change the data store memory and all. It's just a single model, you know. I'm not changing this. I'm just taking a data store write block. After I have taken this data store write block, probably I'm connecting it with my NVRAM service caller block. So once that is taken with this and it is connected with NVRAM service caller block, I think the major connections level at the model, you know, all of this is taken care of at this level. So the next one would be to configure the model with respect to my Autosar mapping and Autosar code generation related levels. So I have done this. All of this is taken care here. I'll quickly make this, save this model. Then what I'm going to do is I'm going to go to this option called as apps. And under this option called as apps, we have something like show more. And under this option called as show more, I am going to go and I am going to select my Autosar related component. Okay, so under code generation, I have my embedded coder, Simulink coder, and all the other code generation related components are there, out of which I am selecting my Autosar component. Okay. So once this Autosar component is selected, so this is a quick self tool which takes care of itself. Okay, so this briefly what it is going to do for me is like I have got my NVRAM blocks, I have my runnables for my given model. So now these runnables, whatever I have, and the corresponding NVRAM block, they need to be mapped to my interfaces. My ports and interfaces of this corresponding model, it needs to be mapped to. So that only we are doing it over here. One interesting thing that one needs to understand over here is until it in MATLAB 2018 and its older versions, okay, that is 2018B, 2018A, or like even in the older versions, when we were doing this Autosar mapping and all, Autosar code mapping and all, when we were doing this was never automated. Okay, so this, whatever that is available in 2019, this is a completely automated one where you just have to click on next, finish. It will take care of everything. Okay, the port mapping and all in the older versions, one has to do it manually one by one. Okay, so in the next projects and all we will be seeing. So in that next projects, okay, or while modeling the Autosar software components for application layer, when we are doing that with respect to application layer, that time we will see how to manually do the port mapping. So here in this case, we are not going to manually do the port mapping. We will make use of this tool, okay, to take care of all the port mapping over here. Okay, so what I will do is I am coming to this set component. So the component name is given over here. The component package information, application is like for what this is like you are using. So this is an application software component that we are taking. So for that you have given it like this. Okay, so basically what I am doing here, application software component is going to be linked to my NVRAM services. That exactly is what I am doing here. And based on that, the code generation is going to happen over here. Okay, remember this, in this you are having an application layer to my, application software component is linked to my NVRAM services and corresponding code generation is done where the BSW config calls and all is taken care of. Sorry, the BSW service calls and all is taken care of. After this, we will be doing a project where exclusively only we are going to take a real-time application. Okay, real-time application as a real-time program we will take in that. For that real-time program, we are going to develop the functional logics, and from that functional logics, we will try to do Autosar port mapping. That is going to be exclusively a software component. That software component is not going to be linked to any of the BSW related applications. All right, so that's why this is, so the component type here is application. So this is a direct model. This is not going to be mapped to any reference model. If you are having a referenced model here, means you can choose a model referenced from Autosar software component. Otherwise, since this is a direct model, you can have this. Click on this option next. So the first one is set component. The second one is my set interface. Under my set interface, again, it will ask for create default based on the Simulink model, or if you have to import from my ARXML. If you are choosing import from my ARXML means if you have any available ARXML file that is available in it. So based on the ARXML file and based on the Autosar schema and other informations that is available in it, it will backtrack to develop a model for you. Okay, understand? So this is what happens with respect to this. So here we are choosing the create defaults based on Simulink model. Next option that we are giving. So once you do all of these functions over here and you take care of it, finally your finish stage has come. So you can click on this finish stage and see what exactly is going to happen. So let's wait for a few moments. So it usually takes some time. Okay, so in this case, I think it has been completed pretty quickly. Okay, so like since this is done, I'll quickly like save my model and I'll keep it. So previously, if you can look at the bottom left corner, no information was there. Okay, but now you can see a code mapping with respect to the Autosar software component. Okay, so now when I click on this Autosar software component code mapping, I am going to get something what is called as an Autosar Editor. Okay, to understand what this Autosar Editor does is and what this code mapping here basically happens, I'll quickly click onto this, okay, which is configure Autosar dictionary. So I'm clicking on this configure Autosar dictionary and it goes inside for me. So here inside my Autosar software component dictionary, I have n number of options that is available with me. Out of n number of options, the first one that it maps for me is my runnable. Okay, I have two runnables that is basically present for me. One is NVRAM init and the other one is NVRAM step. So my system here is assuming NVRAM init as the first with respect to the first port, and NVRAM step again it's like with respect to the second port or 2 millisecond, whatever it is chosen that way. Okay, apart from that, your receiver port and sender port options are there over here. So this is being mapped to at the top level. Okay, so this is a classic architecture. So at the top level, I have my two of my ports that is available over here. So these two ports are correspondingly mapped to my system. So IN1S1S, its corresponding interface, and IS and out1, out2, those corresponding interfaces are also mapped. And one more thing that you need to take care of here is like while you are manually doing, especially, okay, your receiver ports, sender ports, as soon as they are configured, they need to be entered into my SRIF interface. So once that is entered into my SRIF interface, that information, when your code is being generated, that information will appear in my exported XML file. Okay, so because the reason why I'm saying that this specific SRIF parameter is interface is important is because see this final model, this model itself will be considered as a software component. So this, when you are using it against multiple software components, you will have to interact with n number of signals and all. So in that case, having it archived purposefully in a specific fashion, when you are archiving it and when you are keeping it, it will help you in one way or the other. Okay, so that is what we do with respect to this. So with respect to SRIF interface, so for each of these, if you have an SRIF interface, see SRIF is like send receive interface. So each of this will have a data element. So if you have, you have two input ports and two output ports. For both these input ports and output ports, we have our send receive interfaces created, and for each of these send receive interfaces created, we will have my corresponding data element here configured. Okay, so this data element is basically like a read only parameter that is being configured and being used. Okay, so when you have these data elements and SRIF and all like configured, it means to say that any external signal that comes from outside, that signal may be coming from an Autosar architecture or may not be coming from an Autosar architecture. When this is going to come as an input to my system is capable of reading it and accessing that value. So that is basically given over here. Likewise, it is given for all of them. So it reads any output signal and it passes without trying to modify any value at the output level. That is taken care with respect to this one. All right, so this is with respect to my SRIF interfaces. So basically with respect to my port and interface mapping and with respect to my runnable, okay, how they are created and what my runnables are for my system and all. So since like this information is basically configured, the next one we have to take care of is like we are using a BSW component in my model. So since we are using a BSW component in my model, we need to ensure how this BSW element is now taken care of in my model level. Okay, so if you can see here something like a CS interface is there. Okay, if you are using some other component, some other corresponding interface would be activated here. Since we are using a non-volatile memory related component, we are using and this non-volatile memory related component is basically following a client server architecture. Since this is following a client server architecture, Under CS interface, you have my non-volatile memory mapped, and under my non-volatile memory, see, basically I have non-volatile service and non-volatile admin. Okay, so these two are the libraries. So by default, both these will be listed out. NV service, NV admin, like both will be listed out. Under NVM service, there is something called as operations. Okay, so this NVM service operations is the block that we saw over here. Okay, so based on this, we have something like operations, and under operations, you have multiple options. So previous lectures we saw, right? How many number of options are there and what they are and what they are capable of. Under this, we have this information. So this is the write block that we are going to, this is the read block that we are going to see. And under read block, there are multiple arguments which are defined. So these arguments are nothing but objects of my function call. So when my NVM service caller is being called for in my model, whenever this NVM service caller is going to be called for in my model, it is going to make use of two objects with respect to my function call. So what are these two objects with respect to my function call? So they are nothing but my DST PTR and my error. Okay, so DST PTR is nothing but the out. So this is a get block. So this get block has two ports. So the first port is considered as the DST PTR, which is my out port. The next one is my error port. I have taken and I am reading the value, the NVRAM block, whatever value that it is, I'm getting it at this port, right? I'm trying to read it into my data stored memory block. Okay, I'm trying to read it and push it into my data stored memory block. For that, it is mapped to my DSP PTR, and the next one is nothing but my error, where my error is being grounded currently. Okay, so usually you can just like leave it, you can ground it and you can keep it, since that is not going to be of any sort of a significance for us. Okay, so this is with respect to my Autosar dictionary mapping and all. While we are doing the project, or like while we are handling the Autosar software components and their modeling, there are a lot other related features that my Autosar dictionary has. To learn, there is a lot more about my Autosar dictionary. At that time, we will slowly learn it. Okay, so now once that is done and that is taken care of, you can close my model. You can quit and you can close my model. There is some option over here which is like refresh or update my code mapping. I'm just quickly giving on my update to my code mapping. Okay, so previously there was some warning kind of symbol that was appearing, but now that's vanished. So which means it says that whatever we have done is valid and we are good to go to the next level. So in this option that you see at the bottom, like, so this is a gist of what it is and what we can do with respect to this. And in this, you have the couple of functions. So one is the initialize function, the other one is a step function. So once you have defined my runnables in my system, you can choose them appropriately. Okay, so one is init and the other one is step. You can choose that. The next one is with respect to my inputs. Okay, how my inputs are created and how the port mapping element is created. So in the project that we are going to see next, this port name will be given, but how I am going to map it to my corresponding element. Okay, that we will manually do and see is what I said. All right, so this is with respect to the inputs and the outputs. The next one is with respect to the function caller that we are using. So there is only one function caller that we are using in the system. So that function caller is NVM service. NVM service read block is that function caller, and the client port name is NVM service. So that we have not updated. So it is the same. It is taken care of. Operation is the read block. So that information also is like mapped and it is taken care of with respect to this. Perfect. So once you ensure that everything that you have defined so far is correct over here, you can run this. Okay, like this quickly updates and gives you whether things are perfect, things are okay at this level. Okay, so the last stage of the work. Okay, so all the Autosar code mapping and all is done. The last stage of this work is like we can go ahead to generate the code. So under Autosar you remain, there is this option called as generate code. I can go and I can click on this generate code option. Generating the code, sometimes it may take a little longer than expected. Let's see what it does over here. So this is a relatively smaller model where you are trying to map in about the things and the systems. So it should generate the code pretty quickly. With the BSW function call elements, it should be able to generating the code now. Let's wait for a few more moments. So if you can see at the bottom corner, the MATLAB users would know that this is building. So this means that the code generation is in progress over here. And also basically common questions may arise whether you can do this in MBD platform. The whatever model that you have, it doesn't seem like an MBD. Yes, this is not an MBD, but MBD based Autosar code generation is a really challenging and interesting one to learn, which we will subsequently learn otherwise. Also, we touched upon this point in this presentation, okay, about what is the difference between the configuration parameter of a normal model and an Autosar compliant model. So about in detail about more about what my Autosar compliant model and all will do, that we will learn separately, not now with respect to this. Okay, so this is my code generation report. Successfully the code is generated. For this, I'm anyway saving my model. Okay, I'll quickly open the code generation report and see here. So in this, it will give you a different information about my model basically. So what is the hardware type device, what is my system target file, at what time the code exactly is generated. So all this basic information is basically given over here. Okay, so and apart from that, you also have different subsystems, code interface report, whether all the code mapping and others are taken care of. The traceability report also with respect to the model. Okay, so in this under traceability report, you can like see the different mapping and all with respect to the block element, which part of code, which line of code that it is going to map to, that and all is like taken care of. Okay, and the next one is about the static code metrics. So this is a static code that is generated. In order to see the performance of the system, you can go here and performance of the model or the generated code, you can use, or you can see the static code metrics. So likewise, you have code replacements and code assumptions and all. Okay, so the first one that I'm going to do here is like I'm going to select my SWC Autosar NVRAM. Okay, so under SWC Autosar NVRAM, the first thing that we will be seeing is a function caller for NVM service caller. Okay, so this function call for NVM service call starts with a prefix RTE. Okay, so in embedded and all, it was like a different one, but here the NVM for NVM service caller, the function is going to be called for as RTE call NVM service read block, and the function argument that is given over here is SWC Autosar NVRAM DW. So this is how the function is being defined in my C file basically. Okay, and apart from that, other structure of the code as per the logic, the structure of the code is there over here exactly, and it is presumably taken care of. Okay, so we were also telling something called as what is ARXML, how to import my ARXML and the others. So if you can see here, these are some of the auxiliary files which is generated during the code generation, and apart from that, there are some very important files, okay, with respect to the generated code. So they are called as my they are called as my ARXML files. So here my ARXML files, again we have NVRAM component, data type, implementation and interface. So I'll first click on my NVRAM component, because out of all NVRAM component, again only, okay, that looks like a very key and a very important piece of thing with respect to my BSW code that is going to be generated, or like BSW code that is generated now. So in this NVRAM component ARXML, so the first thing it will tell is like the Simulink coder version. What is the model version, at at what time it is generated. And then last, apart from that, it tells you the Autosar schema. So Autosar of different versions are actually possible. So here we are making use of Autosar 4.3.1. So that information is like clearly specified. And then apart from that, if you can see, for each of the ports that is being used in the model, sender receiver interface is created. So all these sender receiver interface, whichever is created and all, between all of this, it's like mentioned in terms of a comment, a single line of comment, it is mentioned and it is taken care of. The same thing is being followed for everything. So if you are using a port, if you're using a data port, or if you're using any other thing, all this is like done and this is taken care of over here. So based on this information from my component ARXML, data type ARXML and all, based on this, you can import it to MATLAB and you can try to create a model out of it. So basically, if you are using manual techniques in order to develop my corresponding C file, H file, and my ARXML files, if you're trying to do it in something like that, means you can import it into MATLAB environment and you can make use of it. Okay, so this is with respect to my code generation report. Yeah, I think with this, the basic working procedure only I have shared in this slides. What it is, what is SS1, and inside SS1 I have two runnables, SS1 and SS2 again. So this is my overall structure of my model, what is what and how it is taken care of, and how I have to configure my NVRAM manager services. So in each and every stage of my Autosar mapping and code generation things and all, in 2019 B it is given like this. Before 2019, that is 2018 B and all, you can even manually go to Autosar Editor and you can see. Now you have to configure this in first place, and only after configuration I can open my NVRAM. I can open my Autosar Editor. It is like that. Previously that was not the case. Alright, so this is with respect to NVRAM manager services, and under NVRAM manager services, how my receiver ports, sender ports and all is taken care of, how my runnables are defined, and how my data store elements with respect to my device, how it is there, how my data store elements are configured, okay, with respect to my model. So all those informations is there. And finally, with respect to this generated code, we saw about how this function caller is defined. Okay, so this generated code includes the function callers to the BSW services. So this function caller value, whatever that we have over here, so this is what we saw some time back. So this has its corresponding DSP PTR, which is something like a display pointer or something. My data index block number and all we saw now. Based on that only, this corresponding NVRAM function calls are defined in my model. Okay, so this is how you basically give that structure, about this NVRAM modeling and related structures we saw, right? So all of that is only like this. And correspondingly for my ARXML also, if you can see, with respect to my this one, okay, for all my imports, outputs that I am using, there are two imports and two outputs used. For both of them, it will be taken care here. And apart from that, for my NVM service, that is read block over here, how it is defined and how the service call is taken care with respect to my ARXML. So all those informations it will be given. So when you are even trying to import this ARXML, automatically my Autosar related information, their data type and any other information if it is there, and that will be like worked upon over here. All right. So with this, the basic modeling of an application software component with my BSW. Okay, with respect to my BSW function calls, how it is done, and the impact can be seen in the generated code. So how this impact is seen at the generated code level, and all those information like we have seen so far, and this is how you would go on to develop a model. Okay, ultimately when you are trying to put it into a loop, what you will have to do is, so this model is essentially for code generation. If you have to put this model into a loop, go to your library browser, under NVRAM manager, go and select my service component. So once you go select your service okay, This you have to do before configuring your Autosar related information. Okay, I'm sorry, before configuring my Autosar code mapping and all you have to do. Since Autosar code mapping is done, you cannot drag any other block and you can't put it over here. You have to dissolve all your Autosar code mapping. Basically, you have to delete your Autosar code mapping and then you have to redo. So once you try to like pull that here and you put it over here means, and then you give the corresponding this name. This client port name is there, no? The same client port name that you have to do this. And once you do that means it will sort of create a loop around it, a simulation loop around it, where a simulation systematic study about the BSW components and their behaviors and all, you can do it over here. So this is purely from code generation standpoint. Pulling in the other service components block and doing it, it will help you to understand from the simulation standpoint with respect to the results and all you can understand. So with this, we have come to the end of this lecture on modeling Autosar BSW components in MATLAB Simulink environment. So the next one would be like about application software components development. So instead of taking some real small models, we will try to take in a real system, try to follow all MBD guidelines. So once like all the MBD guidelines are followed and they are taken care of, how this Autosar port mapping we are going to do and how the final code generation. That is, we won't bring in any kind of NVM related or diagnostic related modules inside that. Only core Autosar software component modeling we will be doing here, and the code generation part we will be seeing. All right. Okay. So with this, we have come to the end of this lecture. Thank you.